Hello, everybody. Thank you for joining us today for another digital event with ArchVision. We're thrilled today for reality capture for the digital twin, where Joe with Direct Dimensions is going to bring us a good overview of what that means. Just to get us started, though, we'll go ahead and introduce you to the crew today. My name is Kelsey. I'm a Sales Operations Manager here at ArchVision. I'm joined by Corey Rubidoux, CEO of ArchVision, and Joe Nicoli, the Manager AEC Services for Direct Dimensions, who will be doing the presentation today. Joe will discuss the basics of how the equipment works that you'll see in the presentation, and how reality capture and the digital twin being utilized today in nearly every stage of a construction project, as well as where it's going into the future. There's going to be a lot covered today, so we will feature a Q&A at the end. Please use the chat to put any of your questions throughout the way there. We will do our best to get to all of them as we go. And with that said, I just want to give you a little background about Joe, and then I will turn it over to him. With over 20 years of 3D laser scanning experience, Joe Nicoli has been a pioneer in the field of three-dimensional as-built building documentation, from the first portable laser scanning systems to the latest in Wi-Fi controlled high-speed instruments. Joe has been on the cutting edge of 3D data collection since the beginning. Today, Joe leads the AEC laser scanning team at Direct Dimensions. With his extensive background in historical preservation and laser scanning, he often lectures to a wide variety of architectural, engineering, and preservation groups. So with that said, I'm turning it over to Joe.
Thank you, Kelsey. Like I said, my name is Joe Nicoli. I'm the manager of AEC services for Direct Dimensions in Baltimore, and I'm going to run you through my little spiel here. I've changed out some of the slides to try and add some little ArchVision things at the end. So we'll see how this goes. If I start running along, someone can give me the hook or tell me to speed up. Here we go. So Direct Dimensions were founded in 1995. So we are coming up, next spring is our 30th year anniversary. So we have about 25 to 30 employees. We're engineers, designers, artists. My background is actually archaeology, and we're kind of a diverse group of people, and we're all kind of cross-trained in all of these different areas of laser scanning. And I think that's the one thing my talk is going to get to, and the one thing I want to kind of make clear is that we're very much a laser scanning company. Well, we're interested in the technology of reality capture. We're not wedded to any one industry. We stay on the forefront of the technology itself. So we're located in Baltimore, kind of all over the place now too. We have people in New York, we have people in Ohio, we have people in Denver. I'm actually calling you from Olympia, Washington. So we're kind of spread all throughout the country, but our jobs are all run out of the Baltimore office. So at Direct Dimensions, we kind of have four main lanes of things that we're doing in scanning. So we do consumer products and vehicles. So anytime a new iPhone comes out, we scan that iPhone so you can make your case to fit that iPhone. If there's a military vehicle that needs an upgrade, we'll scan that vehicle so they can attach new sensors or whatever to it. We do a lot of work in art and sculpture. We do a lot of work for Jeff Koons, if you're familiar with him. We do entertainment and VFX things. So that means we are scanning actors, sets, props, vehicles, locations, you name it. We scanned everything for the Avengers movies. We had people in Atlanta for 2 years scanning all of the actors, all the extras, all of the props, all the vehicles, all the locations. And then we do a lot of work in AEC, which is what we're going to talk about today. And that is everything from, one-room historic structures to stadiums and convention centers and everything in between. Excuse me. So very quickly, we'll go through this. The scanning process. So the laser goes out from the machine, it comes back. And the time it takes, it gets you a distance. And it's doing that millions of times a second on a very well-known azimuth. And so what you get at the end of the day is called a point cloud, and it's just what it sounds like. It's millions and millions of individual points. And what you do with those points can get you your Revit, it can get you your textured model, it can get you drawings, it can get you all of those things. It's all a matter of figuring out what you need at the end of the day. So again, the scanner that you use to scan a basketball is not the same scanner you use to scan a basketball court. I want to make sure that everyone understands that. A lot of time, we'll get a call. It's like, I need scanning. Well, what exactly do you need? Do you need to see the bricks on the wall, or do you just need to see the whole wall? So there's a lot of things out there that are called scanning, and we're going to kind of go through a few of them here, and then we'll kind of dive into what we're doing most of the time in AEC. So again, it's kind of just a sampling of all the different things that are scanners now. You don't need to commit this to memory, but this is kind of our framing mechanism here for what we're talking about. So there's all different manner of scanners, all different scanners, and all scanners do different things. So, and all of them really do have their place. So start out with a handheld scanner. So this is something, if you have from the size of a basketball up to the size of a car that you want to capture, you're going to use a handheld scanner. Can be captured very quickly. It's great on uneven surfaces because it doesn't need a tripod to sit still. Everything is on board the scanner. So just a real quick example of that. This is some ornamentation up at the theater in New York. So you can see it there. It's that hand blender looking thing there sitting on the ground for scale. Quickly capture this ornamentation, and then you can see the level of detail you're getting there. And you can clean up that model. And then that can go directly to fabrication. And we will talk about fabrication because it is one of the great things you can do with laser scanning. We'll talk more about that towards the end of the talk. Another kind of scanner that's become very common these days, this is mobile scanners. So you have a scanner sitting on a car, on a person, on a drone, and you're running around and capturing data. And it has its place. It's not as accurate as some of the other scanning, but it's great for what I like to call, can I get a ladder through there level of resolution? If you need to do wayfinding, if you just need to know that the bedroom is next to the living room, this is fine. You don't need to get the tiny details, and you can capture a lot of data very quickly. So just to give you a sense of what we're talking about here in terms of detail. So this would be a typical laser scan. There's our conference room in Baltimore. And you see with mobile scanning, you get a lot less data. But again, you can still see where the walls are. So it's all about understanding what you need and picking the laser scanner appropriately. Matterport. Hopefully you guys are all familiar with Matterport. They're doing a lot of business now in the residential space and moving a lot into commercial real estate as well. And again, this has its place. Specifically, Matterport's UI is amazing. If you want to understand how a space is laid out, you really can't beat how quick and easily you can do this. What we're actually finding is that some jobs we're doing this both ways. We're doing traditional laser scanning and we're doing a Matterport, a photogrammetry or a photo tour. And that's because a lot of teams are now dispersed, and you can use the Matterport tour to talk about a project, and then you can interrogate the data from the better scanners to actually get in there and get the measurements that you need. Matterport does produce some data that you can use to create 3D, but it's, again, not very accurate. Again, more on the, could I get a forklift through here? Can I get a ladder through there? Where, is the kitchen next to the bathroom? It also has a lot of tools in its UI that allow you to kind of populate a tour. So this is a State Department walkthrough that we helped out on. So there's a kind of Matterport-ish tour, and then we're able to put in 3D objects into the tour. You can fill it up with stories about a space. If you're doing a museum, this is a great way to do a virtual museum with or without 3D objects, but you can tell stories for everything that you're seeing in the scene. All right, hemispherical scanners. So this is mostly what we're talking about when we're talking about doing this for AEC. And they get everything from 50 centimeters away up to 350 meters is the biggest one we have. There are scanners that go out to 1 kilometer. And you're getting everything from, like I had said in the talk, a single room house up to whole city blocks, stadiums, and everything in between. I'd like to give these guys a plug. This is USIVD. We're on the board of this organization, and they are kind of setting themselves out as the experts in picking out a laser scanner. So they are telling, they're out there to tell you if you need an LOD of 350, you need to ask for X in terms of resolution from your laser scanning service. They have a lot of great online resources. All right, the benefits of laser scanning. Obviously speed. I think I used to say that we all used to start it out with a hand tape, but I don't even know if that's true anymore. I certainly started out with a hand tape. And so you have multiple people going out on site, you're pulling tapes, you're marking papers, you're getting hundreds of points a day. And then you upgrade to the total station, you're getting thousands of points a day or hundreds of points a day. Thousands of points a day with GPS, and now we're at millions and millions and millions of points. It's obviously more of a data storage problem than anything else. So to give you an idea how quickly you can max out your point count here, this is the Lyric Theater. This is in Baltimore, and they were renovating the back of house. They wanted to bring in bigger shows, and bigger shows needed bigger back of house to support the sets. So we went in there and scanned the back of house and produced models for that. But while we were there, we took a single scan at the center of the stage just to show how quickly you can capture all this data. And so this would take about 45 seconds now to take this scan. Now you can see it didn't get everything. There's a lot of black spaces in there. The scanner only captures what it can see. It doesn't penetrate. But you can see very quickly, it can capture a ton of data. And every point in there can be measured to every other point. So you can get a lot of data in a minute. Now, if we were actually scanning that space to do a model of that or to do something else in that space, it'd probably take 20 scans. It might take 2 hours of running around there with the scanner to really kind of fill in all of those areas that were blocked from the center stage scan. So accuracy. Most of the scanners that we're using in the AEC world, I like to say they are a single scan is good to about 1/8 of an inch. Multiple scans together, the point cloud you get is good to about 1/4 of an inch. And then depending on the building and the state of it, we're getting, 1/2 an inch in terms of the modeling or drawing that we're doing. That said, we have scanners in our office that go down to the micron level. I have pulled fingerprints off of clay vessels. So again, just understanding what you need when you're asking for laser scanning. Safety, personnel safety. As I mentioned, as it was mentioned, these are high-speed Wi-Fi controlled models. So all you have to do is put this in the lift and strap it down, and you can put it up in a space where you might have had to have someone go up in a lift with a tape measure in the past. So real quickly, you can just take all the measurements you need. Now, how are you going to do that without laser scanning? You're going to go up there with a laser pointer and stick it across. There's also safety of the material and the fabric involved. So if you're dealing with a friable surface, if you're dealing with a hazardous surface, all of this technology is non-contact. So you don't have to touch a decaying plaster surface that you are interested in preserving. Call this on-site access. So this is shock trauma. This is a hospital in Baltimore, and they needed to add some systems to the above ceiling. Well, they needed to know where all these systems are, and this is an emergency room. So they are not just looking at plumbing and drain lines and hot water lines and cold lines or anything. They also have med gas, they have oxygen, they have nitrogen, they have all of these systems up there. So how do you get an existing model of that? Well, you can stick a scanner up there and scan it. And that way you're not putting anyone up on that ceiling. You're not taking every tile out to try and measure this by hand. So was above the ceiling of my desk in Baltimore. You can see we have quite a bit of space in the plenum there, but you can see all the joists, you can see all the HVAC equipment, and this is just from popping a ceiling tile and sticking the scanner up there. So again, like the last example, like how do you get this information if it's not done this way? I assume you're doing a lot of estimating. I have this listed as just remote site access, which is basically just means you have all this data with you. You don't have to worry that you missed a measurement, because let's face it, you probably missed a measurement. Well, is there a door there? Well, you can go right into the point cloud on your computer and figure out how far it is from that door to the corner. So this is just a very quick example. It's an old one. And you can see there's some color lit over the top. We'll get to that in a sec, but very quickly, you can start taking measurements, you can manipulate the data, and you can start seeing what you have on site. So the other thing I like to point out here is you can kind of see them on the floor. There's a couple of black circles on the floor. So these scanners get 360 degrees by 300 degrees, which means it gets all the way around and everything over the top. So the only thing that's missing from your scan is what's directly below the tripod. All right, the process. So let's talk about how we get this data and what we do with it when we get it. So there's a photograph, and there is a color point cloud, and there is the rabbit at the end. Well, what are these steps all about? All right. So what we want to understand when we get on site is, do we need the interior and exterior? What's the resolution you need? Do you need the mechanical, the electrical, the plumbing? Do you need any of that? Do you need the above ceiling? Do you want color and non-color? And this one, I have the example there. So all these scanners have the ability to capture color. So what it does is it'll go once around and capture 3D data. And it'll go back around a second time and capture color. So color can be useful. I'd say the couple of use cases I have for color that we recommend color is if you have a historic exterior that you're interested in documenting, or if you have a particularly confusing pipe room that has color-coded pipes. Those are the couple use cases where it becomes very handy. But just in general, if you're dealing with an audience that's not used to looking at 3D data, sometimes the color can be helpful. The one on the right is we call grayscale or intensity, and the intensity is kind of the fourth value of a scan. So in addition to giving you X, Y, and Z, the scanner gives you a number of how strong the signal was when it returns to the machine. And what you get is this kind of interesting off color based on the materials, based on the distance from the scanner, based on the reflectivity of the materials. And that, so you get a kind of false color image that can be pretty helpful. And then we need to know what your deliverables are. Do you just want the point cloud? Do you need us to tie it to civil? Do you need drawings? Do you need Revit? Do you need something else? All of these things are going to dictate how we go about this. And that's what this is. This is, 90,000 square feet of an office space. So as I mentioned before, the scanner does not see through walls. It doesn't penetrate. So that's kind of an estimation of how many different scanner positions you might need. And we do this in active spaces all the time. All it means is that we knock on someone's door. We say, hey, we're going to take some measurements of your space. It's going to take us 5 minutes. If you want to step out, that's fine. If you don't want to sit there and keep working, that's fine. Don't mind us. We'll be in and out of here in 5 minutes. This is all eye safe. Don't worry about it. So I'm going to talk about Autodesk Recap. So there are many things you can do with these point clouds. By far what we do the most with this is run this through Autodesk Recap, which is Autodesk's point cloud viewing software. So that's going to be kind of our workflow that we talk about today. That said, you can bring this stuff into SketchUp. Other CAD softwares have point cloud viewing software. This is just what most of our clients want. So real quickly about Autodesk Recap. If you have any of the Autodesk suites, you have Recap. And this is just a partial list of what all it will import into from Recap. So if you don't have any of these, Autodesk is Recap, I believe, is $300 a year. So it's a very small price to pay. And what you get with it is a lot of ways to interrogate the data. So this is the full point cloud. So this, you see, it has these mirror balls there, and those can be occupied just like Street View. You can go in there, you can take measurements wherever you want, point to point. You can annotate this stuff. You can actually load this like you would a Matterport tour with information. You can load up pictures, you can load up all kinds of stuff. We also then, to mitigate the large file sizes, we create what's called a unified one, which is just a big dumb point cloud that's been decimated down. So it's much easier to work with. The only other thing to really know about recap is that once you start getting big jobs in here, we will break it up into pieces. Typically, our pieces we'll give you a model of the exterior and then by floor, so that when you take it downstream, you can turn them on and off more easily. So what do we do with just recap? Well, you can do basic measurements. So this is a shopping mall out in Vienna, outside of DC. And they were changing the cladding and the signage on the exterior. Well, the inspector came by while they were working, said, you guys are too close to the power line, and shut them down. Well, they called us and took us longer to drive down there than it did to scan. And we scanned it very quickly. There's some color point clouds you can see. And then very quickly, you're able to take all the measurements you need. You say, well, that's literally our offset. Without a ladder, without a tape measure, this is how far we are back from this, and you're back up and running. Drawings. We're still asked to do 2D drawings all the time, especially for this kind of historic looking. There's just no better way to get a Habs hair level drawing than to start with some color photography and some laser scanning. So like I said, Autodesk, you can dump these point clouds directly into AutoCAD. And there's actually a lot of tools in AutoCAD to work with point clouds once you get them in there. And we get asked all the time for kind of drawings and for 3D. There's no magic bullet that gets you this stuff automatically. We are still manually tracing over the top of it, whether it's drawings or for Revit. And we're doing it all the time. So few examples. Is that a large example of this? This is National Cathedral. Had an earthquake in DC a few years back. Well, National Cathedral took a huge hit. They lost a lot of pieces. And they had a lot of contractors coming in. And they said, well, where are your plans? And they said, well, it took us 100 years to build the cathedral, so they don't actually have any plans, at least not a single set of plans. So we went out there, we scanned it for 3 days with 3 different teams. We were there day and night. And we gave them their plans. We drew every elevation, we drew all of the plans, and gave this to all of their subs. Took a little doing, but turned out very nice. So while we were there, we scanned some of their intricate ornate stonework on the interior. So there's a scanner called a Surphaser that is one of these tripod-based scanners, but it gets down to better than a millimeter resolution. So we wanted to show what we could do with a high-res scanner. So we scanned the pulpit there, and then we knocked out this little model from that. The fun story about that is we showed this to the architect down at National Cathedral, and about a year later, 2 years later, he called us up and said, hey, can we get another print of that? I said, sure. So we printed out this pulpit, and then they spray painted it gold and mounted it and gave it as a parting gift to the preacher that was leaving. So. All right, Revit. So this is mostly what we're doing with our laser scanning, and we're providing Revit. And go through that real quick. Just the width and breadth. I just changed this slide, and it was amazing just how many great things we've been able to do in Revit with laser scan. Again, just like AutoCAD, like AutoCAD, Revit has got a lot of tools for you to actually manipulate the point cloud on board. You can turn on and off the point clouds, and you can see there we have all the layers can be turned on and off. So you only have to load what you need. A lot of the complaints that we get over the years is just how dense this data is, but there really are ways to mitigate that going forward. This is the Tennessee Brewery in Memphis. This is a very typical project from us. This is a 1908 brewery that's being converted over to loft apartments, and I swear to God, a farm-to-table restaurant. I can't tell you how many farm-to-table restaurants we've done. It's a lot. So you have this beautiful little building, and you need to fit your design for your new loft apartments and your restaurant into it. So we went down there. Took 2 of us a day, maybe a day and a half to capture this whole space. You can see they have this beautiful lobby area there. And then there's the point cloud. So right away, you can start taking apart the point cloud. There you can see it's broken into different layers. Right away, you can cut your profile through it. And the first thing, they already knew this, and this is one of the reasons they had us down there, is there's 3 different building episodes here. And they needed to figure out how they were going to create egress between the three different buildings. And currently between them, the center and the right there, they just had someone had blown out one of the walls with a sledgehammer. And again, this is just point cloud data. You can quickly cut your plan view. You can take all your measurements. And then we went through and created the Revit for them. And again, this is just us bringing in that data as basically an underlay, the same way you would bring in a PDF map or anything like that that you have and just tracing over the top of it. But with a point cloud, you're obviously doing it with the exact existing conditions and you're doing it in 3D. All right, change orders. So no matter what group I talk to, I always include this slide because it's very important. So on a typical construction project, rework can account for 12 to 15% of the cost. With laser scanning, you can get that number down to 1 to 3% or less. So if you are doing $1 million job, it's pretty easy to figure out what that math looks like. If you're doing a $100,000 job, it's pretty easy to see what that math looks like. So this was, put out by Autodesk and a laser scanning company, this white paper, but it, so it's a little self-serving, but I think the point makes itself. And here's an example of that. This is a warehouse building that MICA, which is the Maryland Institute for Creative Arts in Baltimore. So they bought this building and they were going to turn it into classroom and office space. It's an old warehouse. So we went out and scanned it. But prior to that, the building owner had given the old plans to the architect, said, no, you don't need laser scanning. Build your plans build your Revit from these old plans. Well, the contractor had us come out and scan it anyway, because the contractor is going to cut steel off site, and they don't trust the old plans to cut steel off site. And they were right not to. So the first thing that they learned was that the building was about a foot off there, because that designed angle wasn't what ended up getting built. And that's no one's fault. That's how this goes. No building is the same when it's built as it was in plans. So they also found that the column lines were short sheeted. Anywhere that you pulled the point cloud, it pulled itself off of some set of the grid lines. It was the same in elevation. Wrong elevation elements, different floor heights, you name it. And so what we did is we helped the contractor kind of tweak the model to better fit their needs. And I do like to point out at this point, we are not licensed architects. We are there as consultants. We are there to help you with your 3D needs, but we are not designers. MEP, as you can imagine from what I was describing before with the hospital, we can do a lot of work in pipes with this system. So real quickly, this is National Aquarium. They had a problem with a tank that was above this pipe room, and they needed to pull all their pipes out and put them all back in. So how do you do that? Well, you do that with laser scan. Historic applications. I think I'm gonna speed through this here real quick, because I think I'm gonna run out of time. Anyway, this is a stone barn up. They call it a stone barn. It's a ruin up by our office in Owings Mills outside of Baltimore. And we went out there just to show what you could do with that surfacer that I mentioned before. So this model is, better than a millimeter resolution. But what I use it for here is to show how you can use this data for analysis. So you can see from that image that wall's leaning. Well, how far is it leaning? Well, you scan it and then you run a plane up from the bottom and you can compare every point to that plane and find out exactly how far out of plumb that wall is. You can do this iteratively. We have a client at DC who has us monitoring a parapet every spring and fall. That thing is heaving. And you can go down there and scan and find out just how far out of plumb it is. Here's the real world example of this. This is Healy Hall down at Georgetown. So that same earthquake, they're like, you know what? I think that tower is leaning. Let's have direct dimension scan it. So we went down, we scanned the tower. And sure enough, compared it to a plane, and up near the top, it's about 2 inches out of plumb. Now, what we can't tell them is whether or not that had anything to do with the earthquake, because we didn't scan it before the earthquake. So, but if they had another one, we could tell them how much it's moved. Floor flatness. This is coming up a lot lately. As buildings are being converted from commercial to residential. A lot of jurisdictions have different tolerances for what you can do for floor flatness. This is a building in DC that was being converted over, and they needed much tighter floor flatness, I believe, because they had those big sliding barn doors that I don't know if they're still popular, but they were very popular a couple of years ago. So we had to go down there. They had gutted the whole place. So it took us a morning to scan just the decking and columns that they had still there. And then we laid out a data point on each floor that they could do their measurement from. So, and then provided them with what we call a heat map. And this is just shows the high and low areas in the floor. It's not a specific fill and grind map, but that's what you would start out with to get your fill and grind. And it lays out pretty well. You can see the low areas there between the bays and the high areas around the edge, where it probably got floated up on the concrete. Another historic thing, let's talk about fabrication here real quick. So this is a great story. This is a historic building out in Frederick, Maryland. So they have this beautiful medallion in one room. They said, well, could we get a medallion like that in the room over? Well, how do you do that? And how do you do it cheap? Well, you go out there with a hand scanner and you scan it. You quickly get your model. And then we sent it to a friend of ours who has 20 MakerBots. And he chopped the model up and printed out the 20 pieces of MakerBot. Then he glued it together and sanded and painted it. Now, is it a beautiful thing when you're up close? Nah, it's not great. But who's up close to this? This is non-weight bearing. It's 15 feet off the ground. It's perfect for what could have been a $10,000 job we did for 1,500. So, and then there's a little more involved manufacturing or fabrication job. So this is Bergdorf Goodman. This is that beautiful entrance you see right on the park. They had a less beautiful entrance around the corner. And they said, well, why can't we have the same entrance on that size? Well, there's no reason. So we went out there, we scanned it. We scanned it with our handheld scanner to get all that stonework, ornamentation, the railings, all of that stuff. We scanned it with one of our tripod-based scanners to get the kind of overall coursing work and brick layout. And the first thing that we noticed was that the door around the side has a different aspect ratio. And so everything had to be adjusted to that new aspect ratio. So we went in there, data, and then we did some digital sculpting. So this is what in the engineering world you would call design intent. And that is you take broken corners and you fix them. You make corners that have been rubbed off, you repair them to 90-degree angles and really just kind of repair this model to what was initially hung up there. And so, and there's the final version. I should note too, this was done for the stonemasons, and they actually sent people down to our office a couple times. And they literally stood over the shoulder of our digital sculptors, and they worked all of this out. And then that data goes directly into a CNC milling machine. This is cultured marble that it's being directly milled from. It's touched up by hand, and then it's hung. So. I like to say that they just left it hanging there and it was stained, that color after about a week, but they did send people out to paint it. All right, civil application. What are we doing here? Kelsey, how are we doing? All right. This is Annapolis City Dock. So we were there to scan the shiplap house up the side street here. You'll see at the end of the animation. The architect that had us scan in that place was also part of an interdisciplinary group, interagency group that is concerned about what they're going to do with the historic district in Annapolis. This is all a historic district. What they're going to do with water rising. They're getting a lot more intermittent flooding. They're getting a lot more just what they call storm surge from water rise. And so they're trying to figure out what they're going to do with this historic district. There's something like 130 buildings that are part of the historic district. Did they document them all? Did they raise some of them? Did they raise all of them? Did they do flood control like they're doing in the Netherlands? This is all part of their discussion. And so what we did while we were there is we went down. It took us part of a morning, and we went down there and we scanned the rest of the dock for them. And once you have this in the computer, you can you can simulate all that. So that's the water. This was about high tide when we were there. That's what it looks like when it's 3 feet up, when it's 5 feet up, and when it's 10 feet up. And 10 feet is what they're actually trying to prepare for. Like, what are they going to do with this historic district if they get 10 feet of sea level rise? So, all right, we'll touch on this, the drone and scanner. So this is something I've been loving with my background in archaeology. We've been doing this a lot lately. And it's combining the HDR quality camera work of a drone with the accuracy of a laser scanner. And what you end up with at the end of the day is a very accurate and detailed color map of the building. So this is the Mayfair Theater up in Baltimore. It's gone through any number of destructive events, most recently a fire. So there's really not much of it left. It was owned by the city and actually the Baltimore Development Group. And so we worked with Preservation Maryland, which is a big, the big preservation group in the state. And our theory was that we could provide this data to Baltimore Development Corporation as incentive to developers and architects to include the historic fabric in their new design. The theory being that if you gave the existing data, it becomes easier to integrate it, and it's not something you had to pay for. So that was kind of why we went out and did it that and we just really like doing this stuff. So we went out there for a morning, we scanned it, we flew it with a drone. See our drone way up there. And again, this took us 2-3 hours. We didn't go inside. It's completely shambles inside. And there's our point cloud that we got from it. More importantly, there is the elevation view we got from combining that with the drone data. So what this is an ortho image. So this is a orthorectified image that has a pixel for every 2 millimeters of wall face. So it's not quite at the level you could do a condition assessment from, but there's kind of no other way to do this. If you wanted to do detailed assessment and annotation of this, we're doing this a lot now for historic properties where either we'll draw some of the lines or we'll just provide this ortho image. It's metrically accurate, it's color accurate. There's no way to get that Mansar without the drone or setting up scaffolding. So we're providing this a lot, and it's a very quick and easy way to go out there without having to draw, whole fields of brick to do your condition assessment for mortar and things like that. Of course, because we went ahead and drew most of it anyway, and then this was provided to the architects, and they are now currently in the process, believe it or not, of taking down this whole facade and moving it back. If you look back at one of the earlier images, or if you look this up on Google Earth, it is right next to the road. And the new development needed it back away. But they're using the 3D data to take it apart stone by stone and reconstruct it off the right of way. I'll give Sketchfab a plug here. These guys are trying to be the 3D content, the YouTube of 3D content online. So we have a lot of our stuff up there, buildings, and then I'll touch on some of the other stuff here if we still have some time. But check them out. We have our own page up there, and you can see some of these buildings and many of our other examples. So I will touch on this real quick, just because we're working with ArchVision here all the time now. We want to get all of these kinds of things into ArchVision and into Avail. Vehicles, animals, consumer products. We're scanning all of this stuff. We did one amazing project, unfortunately, that I'm not allowed to talk about, but a major museum in DC had us scan a lot of their sculpture with the idea of turning them into ArchVision assets so they could do redesign. And again, it worked out great, but we're not really allowed to talk about it. That said, if you have a one-off statue that you need to incorporate into your design, if you have a building owner that wants to be incorporated into the rendering, all of these things are possible. I'll skip through this. That's just a maquette that we scanned and then put next to our office. So in addition to kind of all those other scanning things that we're talking about, we have some of our own custom solutions, and that's how we're getting a lot of these assets. This is a photo rig we have in our office. I believe it's up to 160 cameras now. And you step into the rig, and all all the cameras snap at once, and you get 160 images, and then you can create a 3D model from that. Corey was nice enough to visit us and do that. So, and again, all of this stuff is things that can potentially be assets. I mean, you can have them in any position you want. This is kind of the VFX null position that we scanned everyone in, so that you can put a stick figure inside of and make them animatronic. We also created a pass rig. So this is the same principle. It's photogrammetry. It was created for part scanning for a military supplier. They have millions of different sizes and shapes of parts, and the idea is that you could quickly catalog them in 3D with the scanner we designed. The life that we found for after that is to do this sort of scanning of assets that become ArchVision or Avail assets or assets anywhere else. So we just did 20 cereal boxes for a cereal company that wanted to have their specific cereal boxes. You get the idea that it can very quickly capture all of this sort of stuff and put them into your renders and visualization. And again, another plug for Sketchfab there. I don't know how many of them, if any of them, are downloadable, but if you need a downloadable one, let me know, and we can always make something available to you. But we have all kinds of samples of stuff up on Sketchfab. All right. The FAQs. So we do not need light to scan. The caveat to that is if you want color, all the colors captured ambient lighting, so you would need light there. We don't use targets unless you want to tie in with civil. As long as we know ahead of time that you need to tie in with civil, we can do that. There is no direct creation of Revit from the point cloud. There are softwares out there that are trying. This latest kick in AI has reawakened a lot of these people. Like, oh yeah, AI is going to solve this, and we're going to dump one window model into this point cloud, and it's going to find every instance of the window. That hasn't happened yet, but we keep watching, we keep hoping. The scanners do not detect material type. These files can be kind of large, as I mentioned before, but there are ways to mitigate that. You can always use recap to cut down your point cloud and make it safe. Laser's eye safe, and each scan will take less than a minute. All right. Well, how do you get us to come help you out? It takes about 10 minutes. You give me a call or send me an email. What do you need? What do you not need? If you have any photographs of the site, if all you have is square footage, I'll take it. But square footage doesn't really get to the complexity of these spaces. We will take a schematic map just so we understand how many rooms we're talking about, and we can figure out how long it would take for our people to move through the space. Your level of detail, your output, like I said, give me a call. And I will put in here too, the other challenges is a big one, especially around DC. Do our people have to be escorted? Do we need badges to do any of this? It seems like it's getting worse all the time in terms of what it takes to actually get on site, especially around DC. All right. There we go. All right, I ran a little long, but I think that's it. So if we have questions.
Yeah, just a reminder to anybody who is joining us, please, submit your questions in the chat, and we will read them for Joe to provide some answers for us too. And Joe, that was really amazing, a great overview. And and Corey, I don't know if you had any questions or for Joe, and I know Sam is here with us too. So if anybody has any, the floor is open.
Joe, I do have a question. I don't want to geek out too much and dive into the weeds too far, but are you staying on top of the Gaussian splat?
The splats.
Yeah.
Yeah, we are. So what he's talking about there is kind of the simple way to put it is it's trying to create 3D models from motion using video. And we are staying on top of it. The stuff I've seen is very wonky still. It's still early days. I will say, just as a general note, like having been at this a long time, the photogrammetry, the 3D objects from photogrammetry has come so far. I would have never thought that, I do think that there is a future where there's little to no LiDAR involved at all. And it is all photo based. We're seeing a lot more of that now. And I think the splats will, which is a very unfortunate name, but I do think that that's part of that future. I think it's also, those of you looking it up, I think it's also called nerfing. Is that, or nerfs or
I think
something
nerfs
like that?
were kind of the original
Yeah.
technology. I think I'm not 100% sure, but the splatting I know is now these splats are being able to load into 3D applications, and they can be used
Yep.
and rendered against with ray tracers and things like that.
Yeah, it came out. Yeah,
Material
because that.
level transparencies and things like that are actually coming through without having to be modeled and without having to make a a certain shader for those
Yep.
materials to actually render properly. It's pretty impressive.
Yep. Yeah, I think it's a space we're definitely watching. Yeah, it came out. The whole reason that they call it splats is that it's the kind of a 2D splat that has that surface that you can render on it, as opposed to a point, which obviously you can't render.
Yeah. I know you mentioned a bunch of the equipment and stuff, and if I'm understand and remember correctly, you guys also sell equipment, right? You
We
guys
do.
sell these pieces of hardware and
Yeah,
so
those photo rings we developed at the end were actually developed and are sold, and we resell those. We also resell any number of software. We rep for Faro, for Artec, for Surfacer, Leica to a smaller degree. But we definitely can do that. And that's, that is a path that we go down often, where we'll start out with a service project that becomes basically a demonstration project that, becomes a sale. That's
Yeah.
a pretty typical way that we will go about it.
I would imagine you're seeing maybe contractors buy these devices over architects, and the contractors want to get this right and do this in the field, right?
Well, it's that, and just the kind of way that the architectural contracts are written. There's not a lot of, equipment budget in an architectural contract, because it's all one-off. The capital equipment is not something that's usually written into an architectural check.
Yeah.
You can't buy one of these scanners for a job. Whereas for a contractor, they obviously are bringing their service to multiple jobs. So
Absolutely.
we're seeing some of the low end ones. Architecture firms will pick those up. The Matterport, for instance, we do sell the Matterport, and some people they are buying that up because, like I said, all this stuff has its place. Sometimes you just need to know if the kitchen's next to the living room, and you don't need to know, to the nearest, eighth inch anything. So
How detailed and what's the resolution on the Matterport devices? Are they
I mean, the Matterport at its heart is Microsoft Connects. I don't know if you remember them.
Yep.
That was the initial technology, so it's not great, and the range is very limited. I would say you're not going to get anything further away than about 5 meters, and with any sort of reliability. And they've upgraded the laser in it, but it's still, an inch. I'd say plus or minus an inch.
Okay. Interesting. I hear the word all the time. I mean, folks are saying, "Yeah, we're taking the Matterport out today."
Yeah, I mean, like I said, the UI is really hard to beat, and it's great. The other thing that we do tell clients about the Matterport is Matterport basically owns your data when you use Matterport, because it's all being done on their website, and they're very explicit that they're going to do whatever they want with your data. So that is a concern. We deal with the people at Matterport a lot, and they're very excited about that end of things, like how many spaces they've scanned. And I don't know how to take that when they tell me that's what they're super excited about, is how many spaces they have. But
Yeah.
it is a caution that I tell people about Matterport, is Matterport's going to do what Matterport wants with your data.
Let me ask about production a little bit, because we do have, customers that ask about where teams are located, where the work's getting done and stuff like that. When you guys are doing all the scans to Revit models, are you doing that all in Baltimore, or are you doing that all in the US?
We're doing it all in the US. We're all US citizens. We don't send any data overseas. If it's, we do work all over the US, all over the world. Most of our work is Eastern Seaboard, Richmond to New York.
Yeah.
But that said, I get out and scan. Sent me to Vegas to scan Allegiant Stadium.
Yeah, that actually that could be a whole nother webinar discussion, that whole project. That was pretty impressive.
Yeah, that was fun.
Do you have a favorite project?
That one was fun just because it was fun to be in Vegas for work and not have to pay for it yourself. No, I really like we for a while there we were going out to Mount Vernon pretty much anytime they changed anything. So there's this, Revit and BIM and all of this, it's all about scheduling for, how much paint you need to do and how much lumber you need to build this and all of that. Well, you can use that same system, and there's a firm in DC that came up with this idea of HBIM, which is historic BIM. So rather than populating the all of the back with, how much concrete you would need to do this. They populated the BIM model with all the historic information that they could find from Mount Vernon at the library. So anytime we went out there, we scanned it, and then we went back. Anytime they opened a wall to do repairs, anytime they changed anything, they changed to a halogen fire suppression system, and we went out and scanned again. So, and then we just kept updating the model. So basically, so that rather than you can click on any wood member and find out, what was, when was this installed and what is this? And, all of the historic information is tied to that 3D model. So that was a pretty fun project.
Cool. Well, we have just a couple more minutes left. I don't see any updated questions though, but we put in the chat our email address. So if you do have any afterwards, please reach out. We will get you some answers. And Joe, thank you so very, very much for joining us today. And we look forward to the next one that we'll try to get the ball rolling and plan out. So yeah.
All right.
Thank you, Joe.
Thanks.